to see a topic on the formal languages and automata. So normally you will be feeling very tough for formal languages and automata. So today I am going to teach from the basics, because the subject will be useful for all your entrance exams like GATE or anywhere you are going to write it for IIT or NIT. So now what is formal language automata is, from the basics we will study. We don't want to go in depth for the problems and all as of now. So I'll teach from the basics. So first, before going to formal language automata FLA, so you need to study basics concepts of what and all we are going to use it inside that subject. So basically we are going to use, first thing is symbols. So what a symbols is? Symbols means it's just like a character. All the characters or the digits and everything is said to be as a symbols here. So for example, we can say as so symbols is said to be as a characters. So characters or digits or anything. So now this characters will be like, so like A, B, C, all this is said to be as a symbols now. Okay. So then digits. So digits also will be represented as in symbols, 0, 1, 2, 3, etc. So then we can also tell as a special symbols. Special symbols also is said to be as in what? As in symbols. So like in what, at symbol, ash, then dollar, all this will come under in symbols. So this is said to be as a symbols. Normally you want to know what is symbols first, okay, in this formal language automata. So next what we are going to see is, so next from next to the symbols we have an alphabets. So what is alphabets is, so we are already seen a symbols, right? So that set of symbols is said to be as an alphabets, but it should not be an infinite set, it should be a finite set. So this set of finite symbols is said to be as an alphabet, finite number of symbols. Okay, that is said to be as an alphabet. So generally we will be representing an alphabet like summation equal to, or any A, B, C, etc. Anywhere it will be ending at E, but it should not be like going on, it should not be like an infinite, it is a finite. So or else you can also represent with any other variable, L equal to 0, 1, 2, etc. Like that, it will be ending with 4 or something. It should be a finite number of values inside a set, that is said to be as an alphabet here. Okay, so the set of finite set of symbols inside and set is said to be as an alphabet here. So this you need to be very clear. Then next is, next term you want to know about this FLA is in strings. This is very important. So strings we will be using everywhere. You would have been already studied in C language also, right? C language you would have been studied like a strings. A string is a set of character or a group of characters. If you are joining 2 or 3 characters, then it will come as a word. That word is said to be as a string here. So strings we can set, we can call like in words also. So now I've already said a definition, right? It's a group of words or group of characters is said to be as a strings now. So how you will be linking this with an FLA now? Already we have seen as symbols, and then alphabets also we have seen. So what you will tell, it's a set of alphabets or symbols also we can say, alphabets or symbols. That set of alphabets or symbols is said to be as in strings here. So now how you can represent the symbol? If suppose you are going to have an, for example, if suppose I am going to have an alphabet called, two alphabets I am going to take, so A comma B. So this is an alphabet representation, already we have seen. So this is an alphabet representation. This A is a symbol here and B is a separate symbol. Now this alphabet I need to represent as a string. How you will be doing? So they have given an alphabet. Now I am going to write a string called by using this A and B. So now the strings will be written over an alphabet. So it will be using an alphabet. It's a subset of alphabet we can say. So it's a subset of alphabets we can say. So now how you will be writing? So A, B, or AA, or BB, or BA. So these combinations will be writing as a string. So it's a subset of alphabets. So that's why we are calling this as a string. Okay, so next, inside a string itself, you have understood the definition of strings now, I think. So now, inside a string, there are many things to be known. So what and all it's there, right? First thing is, you want to know length of the string. So how you will be finding the length of the stringers, how you will be finding a length of the stringers, just if you are taking as an alphabet, like in question we have taken like an A comma B, that we have generated some strings like A B, B A, B B, all these things we have generated, right? So for example, I am going to have a string called W equal to A B C D. This is one string now. So how you will be calculating and length of that string is, you will be denoting modulus of W equal to, that is how the alpha string is denoted here, W. So modulus of W equal to number of symbols used inside that string. So how many symbols used? 1, 2, 3, 4. So totally 4 symbols. So modulus of W equal to 4. So that will be the length of the string. Okay, so now you have been studied about length of the string. I think it's clear. So now next topic inside the string itself, we have concatenation, then prefix, then suffix. These three topics you want to know. So what is concatenation of a string is, just you are joining the two strings, that's all. So joining the two strings means I am going to have W equal to AB. So this is one string, and V equal to I am going to have CD. Just I am going to join WV. WV equal to ABCD, that is said to be as a concatenation, just joining these strings. Okay, this can be represented by WV equal to W plus V also we can write. So concatenation we can represent like this dot product, as well as we can represent plus. But there is some difference, but both comes under in concatenation. Okay, that difference we'll see it later when we are solving the problems. So this we can put it for the concatenation. Then what is prefixes? Prefix in the sense, if suppose we are going to have a string called W equal to A, B, C. What is a prefix? Prefix in the sense it's in coming before. Before it's said to be as in prefix. So now how you will be writing the prefix of the string? So they have given a question like W equal to A, B, C. You are going to write the prefix of that string. So how you will be writing that prefix of the string is, so just you will be writing the prefix of the string will be, so you will start from this end, that is from the left hand side, that is before. So now A, comma AB, comma ABC. This is the prefix of the string. So you will be writing like this. So whenever the string is given, you will be starting from the pre-string you will be starting. That is before the string starts, you need to start from that term. That is left side term. Okay, whereas the suffix is the quite opposite of this. So what is the suffix of this string? The same string, how you will be writing this, you will be starting from the rightmost corner of the string. So that is W equal to C, okay, C comma BC comma ABC. So that is suffix. So now C I have written, and then BC, from right we need to write, then ABC. So you have seen the difference here, right? So this is prefix and this is the suffix of the string. Okay, so this will be the difference between the prefix and suffix of the string. Okay, so the next topic on the same thing. So these and all, it's very important. So before going inside the problems, you want to know this terms. First is symbols, what is a symbol, and what is an alphabet, and then what is a string, and then one more term, very important term we have is a language here. Okay, that's why we are going to see now. So language, what is language here is, so language is again a set of alphabets, a set of strings under and set, it's said to be as a language here. So now this language will be represented by set of strings. Okay, that is said to be as a language here. So you have already, we can also say that it's a subset of what symbols or subset of alphabet, but general meaning how you will be terming as language will be set of strings. So set of strings only you need to tell. So if suppose I am going to have like this, summation equal to AB AA, BB, etc. It will be going on. So this is said to be as a set of strings. So this one term is said to be as a string because it's a combinations of alphabet. So this is one string, this is one string, this is one string, this is one string. All this set of strings will come under a language. Okay, so now this set of strings is said to be as a language. Similarly, we can write it in digits also, it's not an issue. So it's, I have given an example like in variables I've given, but you can also write like in summation equal to 0 1 1 0 0 0 1 1 1 0 1, like that. It will be combinations of digits also it may have. Okay, anyhow it will be like in combinations of strings. Set of strings is said to be as a language. So we can also say as a subset of strings also we can say. So this is what the language is. So mostly we will be using this type of language inside the problem solving. Normally they will be asking like convert this language into an DFA or convert this language into an NFA, represent a DFA for this language, like that and all they will be asking questions. So when you are solving the problem you can understand what it is. So this is a basic model of the language. So for your more understanding purpose, I'll give you one example. So you all know the palindrome concept. So it's a reverse of a string is a palindrome, right? So suppose I am going to have W as a string called 101. Okay, what will be the palindrome of this? Palindrome will be the reverse of the string. So reverse of the string will be denoted by W power of R, right? So now this W power of R is also the same thing. So 101. If you are reversing this string, you will be getting 101 again. So this concept is said to be as a palindrome. Palindrome, right? So now this concept, how you will be writing as a language here is, so the reverse of the string can be denoted as a language here. Because why? Because W reverse of the string can be denoted as a language also. How? Because already we know W is 101, then this reverse string is also the same. Now we will be writing that W power of R such that where L belongs to W. So already L is a language, already L we have. So what I said, L is a set of strings. Set of strings means I am having a string called 101 now. So this L is 101. This L belongs to W, but this W is such that it is similar to W power of R as a what's reverse of the string. So this is how we will be denoting a language. Okay, so you need to understand the concept and you need to write a language. Most probably you will be converting the term into a language and language into this DFA and NFA, all this finite automated conversions we will be doing it. We'll see it in depth when we are solving the problems. So next, after converting this language and all these things, after knowing this language, after seeing the language, the important topic we want to see on the clean closure and positive closure. Positive closure we need to see. So what is clean closure is, so you have studied already language, right? It's set of strings is said to be as a language we have seen. So now this set of strings you are writing like summation equal to AB, BA, AA, BB, like that we have written set of strings inside a language. Now how you will say that clean closure and positive closure is, if suppose you are going to insert an empty string at the beginning. So this empty string epsilon, then it is said to be as a clean closure. Okay, this epsilon is said to be as an empty string. Empty string is said to be as an epsilon, or we can say as a null string. Nothing is there inside this string, then it is said to be as an empty. So you need to add this empty string inside the language, then it is said to be as a clean closure. Positive closure means you won't add this empty string. Without adding an empty string, you will be writing a language. That is a combination of strings you will be writing. That is said to be as in positive closure. So now how you will be denoting this empty string and this clean closure and positive closure is, so if you are writing summation star, you need to mention summation star, then you will be including this empty string. Okay, then if you are not putting an empty string, summation plus, that is a positive closure. Now you won't add an empty string AB, BA, AA, BB, you will be writing. This is the difference between a clean closure and positive closure. So generally this closures, it will be the combination of strings. It won't be like infinite and all. It may be infinite. It will be going on. Only thing is you won't add an empty string. Here you won't add an empty string. Here you will be adding an empty string. Okay, that is the difference between the clean closure of the language and positive closure of the language. Okay, so these are the basic, very basic things you want to know inside to study on this formal languages and automata. From the next class we will be going in depth on what is automata and what are the different types of automata we have, and all the problems we'll be seeing one by one in the next part of the class. Thank you.